Quantum numbers. The 4 famous quantum numbers. The difference between this video and the similar ones is in this video we gather all the 4 quantum numbers in one page and explain what they are and the range. That's it. At first, let's find out what good are them. The most usage of the quantum number is specifying any electron in the atom. In fact, the quantum number are the identification of electrons in atom. Now it's time to introduce the first quantum number. Its symbol is N, principal quantum number. As you see, it shows the shell number in an atom. Any atom contains several shells. An electron being a bigger shell, its energy is higher. So the shell number shows the energy level. The range for the N starts from 1 to more than 7. For example, in electron configuration, we write 3s2. Number 3 tells us that the electron in s2 stay in a shell number 3. So this is the story of first quantum number. The next quantum number is L. It's called orbital quantum number or azimuthal quantum number. Its application is describing the subshell and kind of them. For example, when the L is 0, the kind of our subshell is S, that it has only one orbital. An orbital, the maximum number of electrons that could be are 2. Or when the L is number 1, kind of subshell is P, and P has 3 orbital or 6 electrons. And when the L is number 2, the kind of our subshell is D, that it has 5 orbital and 10 electrons. And the last, when the L is number 3, the kind of subshell is F, it has 7 orbital or 14 electrons. But wait a minute, what is orbital? Orbital is a cloudy place in an atom that the percentage of the existence electron in there is more than 90%. That's it. Now it's time to talk about the range of L. L starts with 0 to n minus 1. It means the L can take 1 unit less than n. For example, when the n is number 3, the most number of L is number 2 because 3 minus 1 is 2. And we know when the L is number 2, our kind of subshell is D. The next quantum number is m sub, the magnetic quantum number. It distinguishes the orbital available within a subshell, and its range is between -L to L. For example, when our subshell is P, so the L number is number 1, and the m sub L is from -1 to number 1, and it's become -1, 0, 1. With this example, we can understand all of the m sub L of all subshells. For example, when the L is 0, our subshell is S, and the range of m sub L is only 0. The next one that we talked about it was P, that the number was 1, and m sub L range from -1, 0 to 1. When the L is number 2, the kind of our subshell is D, so the m sub L is from -2 to +2, and it's included -2, -1, 0, 1, 2. And last, when the L is number 3, kind of our subshell is F. M sub L range from -3, -2, -1, 0, 1, 2, and 3. We see all of this number of m sub L, the bottom of all of the orbitals of subshells. So each one of the number in m sub L describe one of the orbital in a subshell. The last quantum number is shown with m sub s. It is the spin quantum number. It describes the angular momentum of an electron in one orbital. And as in an orbital, the maximum number of electrons are just 2. M sub s can have only 2 numbers, -1.5 and +1.5. Now it's time to find an electron in an atom with 4 quantum numbers. For example, I choose these 4 quantum numbers to find out the electron with these 4 in potassium. Potassium atomic number is 19, so in the natrium mode it has 19 electrons. So we write its electron configuration. If you don't know how you could write the electron configuration, I strongly recommend you to see my video to learn it in just 5 minutes. it. So we write its electron configuration. We start with 1s2, then 2s2, 2p6, 3s2, 3p6, 4s1. So we start finding our specific electron. As we see, its n number is 3. So we'll highlight all of the subshell with shell number 3. We have 3s2 and 3p6. Then the question tells us the L number is 0. And we know when the L is 0, our subshell is S. So we ignore P and we'll search in 3s2. And it said M sub L is 0, that it's normal because when the L is 0, the M sub L range is only 0. So we draw its orbital with 2 electrons, and the last told us that M sub S is 1.5 positive. So find it. Let's check out one more question. This question asks us to find out how many electrons are in arsenic with these quantum numbers. So at first we write arsenic electron configuration. Arsenic has 33 electrons in neutral mode as its atomic number is 33. So you start again with 1s2, then 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p3. At first question told us that the L number is 1, and we know when the L is 1, our kind of subshell is P. So we select all of the P in our electron configuration and draw their orbitals. Then it told us M sub L is -1, and we know P has 3 M sub L, that they are -1, 0, 1. So we have a -1 in 2p6 that it contained 2 electrons, and again we have a -1 in 3p6 that it again has 2 electrons, and we have a 1 minus in 4p3 that it has 1 electron. So 2 plus 2 plus 1 become 5. And it's the answer of our question. It's done.